topic. Organ transplantation saves many lives, no issue. But there is a lot of side effects after the surgery and rejections. For combating that, we are introducing a new method called as lab-grown organs by artificially creating like the developed organs or obtaining cells from the human itself and bioengineering it and growing it under various cultures and making an organ. It's nothing but lab grown organs. The need for lab grown organs, firstly, there's a shortage of organ. All organ donation is done by donors who meet with an accident that causes the brainstem damage, which is the main reason why the person is brain dead, who donates the organs. It is in a shortage, as we see. High risk of organ rejection. When the HLA typing doesn't match, the organ gets rejected and the patient is put on a long term till the mortality. The patient is given immunosuppressants, which is very dangerous because it can cause various infections. Advancing in regenerative medicine and repairing damaged organs, by this lab grown method, we can create certain grafts which can repair the already damaged organ rather than doing an organ transplantation. And ethical and legal reasons. Now, certain illegal practices like organ trafficking is still happening today. To avoid that, we can use this method or lab-grown organs, which will combat that issue of organ trafficking. Technologies behind lab-grown organs. First, we have the stem cell technology. It uses the body's own cells, which are bioengineered. Either they are embryonic stem cells or pluripotent stem cells. 3D bioprinting. Here we use the bioink, that is the cells and the biomaterials, and we coat the organ layer by layer, which will eventually develop into a fully functioning organ. Organ on a chip. Here we are using microfluidic devices which will be inserted into the human and will mimic the structure and functions of the organ. Decellularization and decellularization. Here we convert the donor organs respective to the HLA typing of the recipient organs, and we can do the transplantation and not worry about the risk of rejection. Current success stories of lab-grown organs. Initially, we have a lab-grown bladder by the scientist Dr. Ann Anthony in 2006. He has created a lab-grown bladder, which is avoiding the patient from going through dialysis and also various other transplants. Artificial trachea or the windpipe. A patient came to him with a case of cancer, tracheal cancer, which was made by Dr. Paolo, a Swedish doctor, in the year 2011. Lab-grown skin. Now, for burn victims, there is a scar lifelong, and the wounds may never heal. To prevent that, with third-degree burns, we are using this lab-grown skins as a skin graft to replace the burned skin. And 3D printed heart tissue. Now, in patients with heart failure, always a surgery is recommended when it is in the end stage of the heart failure. So, we are using the bioengineered cells of the heart and creating and making it into a medium like this, and we have generated a small beating heart. This proves that 3D bioprinting can help in organ growing into a particular medium. Challenges that we face in this procedure is that vascularization. As we know, human body, for an organ to function, we need a rich blood supply. If the blood supply is not given proper, the organ might undergo necrosis and may not function properly. And organ maturation and functional integration. Here, these organs are not fully functional, but they are, compared to the diseased organ, they are completely functional. And immune rejection and compatibility. Still, we face the problem of immune rejection, where these organs, when they are still grown with the stem cells, are also facing immune rejection because of certain conditions like autoimmune conditions. Ethical and regulatory challenges. Here, the this method is still under clinical trials. It is certain procedures are FDA approved, certain are not, and high cost. As you know, this kind of research is only possible with the millions of dollars of research and funding. Future prospects and research. Now, what kind of developments future we might see is that advancement in AI, machine learning for lab-grown organs. Artificial intelligence and machine learning are revolutionizing the tissue engineering and organ regeneration, optimizing the organ growth and functioning in the lab, grown organs, to make the organs grow fully and functionally. Research is being done by particular scientists in the field. And next gen bioprinting for lab organs. Bioprinting is always a promising approach for as compared to 3D, as compared to the stem cell technology. Now, what is the advantages of lab-grown organs and traditional organ transplants? Bioprinting using patients' own stem cells and scaffolds and bioink. So there is a less chance of rejection as compared to the traditional methods of organ transplant. Organs can be grown on demand. That is, a patient does not need to wait for the donor to give the organ and can be generated using certain bioengineering principles. Custom made for each patient. This comes under again personalized medicine, where a person's body is only being used for generating the new organ. Whereas here there is a use of other person's organ and higher chances of rejection. Functional lab-grown hearts and kidneys are still, like I mentioned before in that example of success story, a certain heart was prepared and it was fully and functionally beating. Potential impact on global healthcare. It reduces the dependency on the donors. That is, the patient does not have to wait on the donors to receive a transplant. Minimizing the organ trafficking. Organ trafficking is really a very illegal approach for this organ transplant, and this organ trafficking we can combat this by using these procedures. Improvising the accessibility. Organ transplant becomes widely available. That is, when the patient's organs are being bioengineered in the lab, we can expect that everybody has accessibility to this, but lowers the long-term costs. As you know, immunosuppressants are very expensive medications and certain families cannot afford that. So we can reduce the rejection-related complexes or expenses in the future. Conclusion. I would like to conclude my presentation by saying lab-grown organs are groundbreaking advancements in transplant surgery or regenerative medicine, and these are offering a potential solution for combating the problem of organ rejection, and with enough research and funding we can proceed with this as a promising approach for patients who are having organ failures. These are my references.